Now let us see a new data structure which is called a linked list used in place of arrays. We are having many disadvantages while using arrays. Some of those can be removed when we use linked list. So a linked list is a data structure which can change during execution. That means during execution of the program, the nature of the list can be changed. It means that we can request for new memory or release used memory while the program is in execution, which is not possible in the case of arrays. The nature of array is static. When we declare an array of size 50, it cannot be extended or it cannot be reduced. Whereas in the case of linked list, we can go on adding many elements into the list as far as memory is available. We can also release those memory when we don't want those data in future with the execution of the program. So that is the main advantage of using linked list. It's a collection of elements as in the case of arrays. The difference is that in array the elements will be in consecutive locations, whereas in linked list it will be scattered around in the memory. So collection of elements are called successive elements. One element will be appearing after another element, and these elements are connected by pointers. Those pointers are holding addresses of these elements. We have already learned that pointers are used for locating memory addresses or memory locations. The last element must point to null, or the content of the last element should be null. The address content of last element should be null. As I have said, the linked list can grow in size as well as shrink in size during execution of the program. Therefore, its nature is considered to be dynamic in nature. It can grow or shrink as the program requires. With this, the memory space is utilized maximum. Wastage of memory is minimum when we use linked list. It's not the case with arrays. A pictorial representation of a linked list is shown below. This one forms an element. A is an element. Here B is an element. C is an element. Each of them are represented using a box having two spaces or two fields. One is storing the information. Here A, B, C are the information. It can be numerical values, alphabetical values, or any other type of values. It is not necessary to store single values. We can have multiple values also. Anyway, this cell is divided into two portions. One is for storing information and the other is for storing address of next cell. So each cell should have a location for storing address of the next cell. I will not be using the word cell here. Instead, I will be using node, the word node, N-O-D-E, node. So a linked list can be called as a collection of nodes. These three nodes are forming a list, and that list is called as linked list. Why? Because these nodes are connected using links. This is a link. This arrow mark is called as a link. This is a virtual representation. Actually, these lines will not be there. Here we will be having the address of this node. Here we will be having the address of this node. And as said here, the last element, this is the last element, should point to null. A null is represented as like this, because there is no node after this last node. We don't have any address to store here. So this is the representation of linked list. And we have seen that when we represent an array, the address of an array is called as base address. What is a base address? It is the address of first element in an array. Similarly, if we want to refer to the values of linked list, we must have address of the first node. So we should have the address of this node, then only we can go from here to here, then here to here. Okay. Therefore, we will be using a pointer like this to represent the address of this linked list. So here head is the pointer. Are you remembering what a pointer means? We have studied or learned about integer pointer, float pointer, character pointer. All these represent memory locations. A memory is having addresses. These addresses are the content of the pointers. So we have to declare the type of pointers, which means that if we declare a pointer variable of type integer, then that variable or pointer is used for pointing to a location where we can store integer values. Likewise, if we use a pointer, node pointer here head is a node pointer, which means that this node pointer will be having an address, which is the address of first node. Similarly, all these are node pointers. Why? Because they are storing the address locations of another node. So the first node will be having address of the second node. Second node will be having the address of third node, and so on. It will go up to null. The last node should point to null. Null means an invalid address. That's all. So for entering into a list, we must have a node pointer. Normally it is referred to as head or start or anything of that sort. So how to keep track of a linked list? If we are having a list with many values, we must utilize that. For that, we must know the address of the first node, which is the address of the linked list, which is known as the address of linked list. When we enter into first node, from there we can go on to the second, then to the third, and so on. We can move from one node to another using the address portion of each node. So first we must have the address of linked list. It will be the location value of the first node or first element. Normally it is denoted as start or head, anything of that sort. This is purely based on the user defined words. It should not be reserved words. So the user can formulate their own words for representing address of the linked list. Then to facilitate the dynamic nature of the linked list, we can perform addition and deletion of unwanted nodes. We can add new node for storing new values and remove the unwanted values using the delete option. So insert and delete are the two options for performing the flexibility of the linked list. Now let us see how to create a node. For creating a linked list, we must create node because linked list is a collection of nodes. So we must create the node first, then link those nodes into form a linked list, form a group. So for this we will be using a data structure called struct. You must remember how to form a struct. The main property of a struct is we can combine different type of values as against arrays which stores only homogeneous information or data. We can combine or store different types of data in a struct. So here we will be using struct word, and this is a structure tag which is named as a node. It is having two fields. Minimum, I told you that we should have minimum two fields for forming a node, and one is data, integer data part, which can store, if we declare it as int, it can store normal counting numbers, whole numbers. If it is a float, we can use decimal numbers. If it is a character, we can store alphabets. So likewise, we can have many informative elements of different types. For easiness, I am using only one value field and one address field. So this is an integer data field where we can store the information, and this one is the compulsory field which should store the address of next node. So using this field only we will form the link for joining multiple nodes. So this should store address of next node. So this is a next, here next is a node pointer, and this node is a member of this node. So whenever a node pointer points to the same structure, this is called as self-referential structure because it is pointing to the same type of element. So linked list is a collection of self-referential nodes or nodes formed using self-referential structures. So here we are declaring structure variable also. We must include the beginning address of a linked list. For that I am using the word head. So this is the structure part of creating a linked list node. In all the programs we will be using this type of structure definition. It should have a data part and a link part.